Hello and welcome once again to Learning Together, sponsored by the Brosis Foundation. What is the purpose of this? It's really trying to make additional resources available to those who may need help in math and English. So we do have sessions in English, and as you can see, we also have sessions in math. It's only providing additional help to whoever may need help, and all of us need help at times. So this is great in that you can access this 24/7 as many times as you want, and it's free. And as I said, it's sponsored by the Brosis Foundation. Today, we're going to be looking at a topic that some people find to be complex, but I promise you, I'm going to break it all the way down and go step by step so you can get a good grasp as to how to handle rational expressions. In my 25 years of teaching, I've observed that as soon as you see fractions, there are some people who just freeze. They just have a mental block about fractions unless they have a calculator. But truthfully, if you understand the basic principles, they're not as scary as they look. In other words, the bite is way less than the bark. It looks difficult, but it's not. And again, I'm going to lay it out as simple as I can, step by step. So this section might take us 2 or 3 sessions. So bear with me, I'm going to go slow because at the end of it, I want you to feel confident in your knowledge. So in English world, whenever you hear the word rational, you tend to think that it's, say, reasonable, it makes sense, as compared to irrational, which is just totally nonsensical. So irrational does not make sense. Rational, yes, it does make some sense, it's logical. This has nothing to do in math about sense and nonsense, no. So rational expressions in math has nothing to do with reasonableness, nothing at all. There is no relationship between the English interpretation of rational and the mathematical application of the word rational. All it means in math, if you have the word rational, it means that you can write it as something, you can write it as a fraction. That's all it means. It has a top and a bottom and a line separating the two. So you hear about rational numbers. Are numbers that can be written with a number on top and a number on the bottom. And then you hear about rational expressions. It's the same thing, except that with an expression, you will have a variable somewhere, whether top or bottom or both. So a rational expression is a fraction that has variables above or below. Okay, that's all. It's a fraction with variables, that's it. And it could be a single variable, or it could be multiple variables. So that's what a rational expression is. So we're going to do some fun stuff working with rational expressions. So today we'll work on rational expressions, see how far we get. And if we manage to complete, a broad section of it, then the next time we meet, we'll talk about solving rational equations. That's going a step higher. So today we're going to do stuff like simplify, add, subtract, multiply, divide rational expressions. So by the time I'm done, you should be experts at this. And if I have to do 2 sessions with this, I'm perfectly fine with that. Okay, so I'm not going to rush. I'm going to take my time and lay it out step by step. Okay. Rational numbers or expressions That's it. Can be written as fractions. That's all. Okay? Examples. 7/2. That's a rational number. 2/5. That's a rational number. X/3. That's a rational expression because you have a variable. X plus 5/2. That's another rational expression. 4/x minus 3. There's another rational expression. X squared plus 7x over plus 1 over x plus 2. That's a rational expression. So you can see it can get very complicated very fast. And you can write, x cubed minus 1 over 2x plus 3. Okay? So all these are examples of rational numbers or rational expressions. I can show you this. If I gave you the number 8, that's also a rational number because I can write it as 8/1. So I think it's appropriate for me to give an example of an irrational irrational numbers cannot be written as fractions. Examples. √2. √2 can never be written as a fraction. √3, √5, √7, 5, √6. Anything that cannot be broken down, can denote have a perfect square, is considered an irrational number. And those numbers continue forever. They just keep going. If you were to find them as a decimal, they just keep going. They do not terminate, or they do not have repeating decimals. But I'm not going to waste time to go into those other definitions. They basically have radicals that cannot be simplified. Okay? So now let's go into some operations using rational expressions. Now, I spent a previous session working with fractions, extensively working with fractions. I also spent a previous section working on factoring. So factoring will come into play a lot when working with rationals. And the principles associated with fractions, just the numbers, fractions, will be applied when dealing with rational expressions. So I'm going to start with something that looks like this. Let's do simplify. One, 2x plus 2y over 3x plus 3y. As I told you, I'm going to go easy as ever, slow it all the way down, and then see how it works, okay? So let's see how this one goes. As you look at remember, you have numerator, denominator, and the line separating the two. So your numerator, your denominator, line separating the two. I should give you a little tip. I'm going to give you a new word. Add a new word to your vocabulary. So this, we all know, is a numerator. Can that be seen? Is that, oh, that's not good. This is too pale. Let's see if my red is better. And this, okay, this is better. Denominator. Okay. Now, I bet you, most of you do not know the name of the line that separates the numerator from the denominator. It has a name. Yeah, it does. I'm going to give you that name. It's called the vinculum. Vinculum, that's the name of the line that separates your numerator and your denominator. So numerator is on top, denominator is on the bottom. The vinculum is the line that separates the two. That's a new word for you, okay? Good. So what do? The best thing to do when asked to simplify a rational expression is to see if perchance you can factorize. Look if there's anything common to the top and isolate it, and look if there's anything common to the bottom and isolate it, and then see what happens. When I look at this, I notice I could factor out a 2. It becomes 2 times x plus y over 3 times x plus y. You have x plus y on top, x plus y on the bottom. This divides into that goes 1 time. So these two, basically, they cancel each other. And the answer, therefore, is 2 over 3. So that will be the answer for that first rational expression. It simplifies to 2/3. Okay? Let's try another one. If I gave you something like that and said, simplify that. Again, something that is very, very useful when trying to simplify rational expressions is to factorize where possible. So as I look at this, I say, oh, wait a minute. Let's try something. Can I do this? I think for this, I'll end up with x plus 3 times x plus 2. That's the factorization of that. X plus 3 times x plus 2. Again, I spent an excessive amount of time factoring algebraic expressions. So there it is right there. And then the bottom is x plus 3. So x plus 3 here, and then multiplying by x plus 3 on top. This cancels this. Our answer is x plus 2. Let's try one more like this. Okay, so let's see what that is. X cubed minus 3x squared minus 15x all over x plus 2. The moment I look at this numerator, I notice that there's x common to all 3 terms. So I could factor out an x. So we end up with x times x squared minus 3x. Oh, yes, minus 15. Okay, so far so good. Nothing seems to happen so far. But now when I look at this trinomial, this quadratic trinomial, I'm going to try and see if I could factorize that further. What do we end up with? Well, if I'm not mistaken, I think we end up with x times x plus 2 times x minus 5. Okay, x, I'm sorry, I should have at the bottom here. Let's put, oh, never mind. X plus 2 . Okay, I made a mistake. This should have been 10. My mistake, sorry. Yes, I just wrote this out of my head. So x plus 2 and then x plus 2. So let's back up a little bit. In order for this to simplify, these two numbers have to multiply to give me negative 10 and add to give me negative 3. So that's perfect. So now I have an x times x plus 2 times x minus 5 over x plus 2. So these cancel, and we're left with just x times x minus 5. X times x minus 5. Okay, and that would be, oops, let's move this a little. That's a final answer, x times x minus 5. That's your final answer. That was a little ugly, but that's what that is. Let's try something else. Okay, let's try this one. (17xy) over 24z times 12x over 34y z. Whenever you're multiplying and you have the same thing on top and the bottom, they will cancel. For example, if I have 2 times 3 times 5 times 6 over 2 times 5, anything that's common to the top and the bottom will cancel. So this cancels that. This cancels that. So we end up with 3 times 6 is 18. It's the same principle when dealing with rational expressions. If there's something on the top and something on the bottom and you're multiplying, then you can cancel. If you're adding or subtracting, you cannot. That is very important. Let me say it one more time. If you're doing multiplication and you have the same thing on top and as on the bottom, they will cancel. But if you're doing addition or subtraction, you cannot cancel. Okay, so here we go. As I look at this, I see this y cancels this y. There's no x on the bottom, but I see x here. And when I look at the 12 and I see 24, I say 12 into 12 goes once, 12 into 24 goes 2 times. I see 17 here and I see 34. 17 into 17 once, 17 into 34 2 times. So now I want to put what's left over. There's an x, 1x, 1x, that gives me x squared. On the bottom, I have 2 times z, and then 2 times z. So that gives me 4z squared. So look at what we started with. We started with a complex expression and ended up with a very simple expression. All we did was we canceled like terms from the top and the bottom. That's it. Let's try another one. This one says 52x to the 10th y over 25 a cubed b squared times 45 a to the 5th b squared over 13 x squared y to the 5th. Okay, so we're multiplying. The dot means multiplication, so I can put a dot or I can put a multiplication sign. In math world, it's the same thing. Okay, so we're gonna go slow to simplify. What do we have? I see 13 and I see 52. I know 13 goes into 52 4 times. So I can cross this out and put 4. I see x squared and I see x to the 10th. So I know that the x squared and the x to the 10th, when you divide like terms, you subtract the exponents. When you multiply like terms, you add the exponents. So this is going to give me x to the 10th divided by x squared is going to give me x to the power 8. But before we go there, let's see if there's anything else we can simplify. I see 25 and I see 45. I could divide top and bottom by 5. So 5 into this goes 5. 5 into this goes 9. So am I done with all my numbers? I think so. So I have 4 times 9 and 5 times 1. So 4 9s, 36. And 5 times 1 is 5. So those are the numbers. When you're working with multiple variables, it's always better to write the variables in alphabetical order. So we have x, we have y, we have a, and we have b. So therefore, you want to go a, b, x, y. So let's take care of the a's right now. So we have a to the 5th, a to the 3rd. So a to the 5th divided by a to the 3rd is going to give me a to the 2nd. And if you wanted the evidence, I can show you a to the 5th divided by a to the 3rd is equal to a times a times a times a times a. That's what a to the 5th is. A to the 3rd is a times a times a. And what did I say? If you have the same item on top and bottom and we're multiplying, we can cancel. This cancels this, this cancels this, this cancels this, and we're left with a to the 2nd power. And that's the same as just saying 5 take away 3 gives me 2. So a to the 2nd power. Let's go for b. We have b squared on top, b squared on bottom, the exact thing. So they cancel. B squared divided by b squared is 1. So they cancel. This is gone, that is gone. So we're finished with A, we're finished with B, we're finished with the constants. So now we're left with x and y. X to the 10th divided by x squared is x to the power 8. And then what do we have? We have y on top, that's y to the power 1. If the exponent is not written, it's to the power 1. And this is y to the 5th. So you have 1y on top and 5 y's on the bottom. So one of these get canceled by that. So we're left with y to the 4th on the bottom. Make sense? Good. So look where we started. We started with these 2 ugly looking expressions, and we're able to reduce them into one simple fraction. Okay, let's move on. It gets a little bit more advanced as we're going progressively more complicated. So let me erase this so we can see clearly. I think I want to use the red just for something different. Let's do the red. Doesn't mean that it's more difficult. I just want to use something different. So, how about this? B squared minus 81 over B minus 9 squared times 3B minus 27 over 3B plus 27. Now, let me warn you from now. I have said before, and I'm going to say it again, that when you have the same thing on the top and the bottom, you can cancel only if you're multiplying. Here, I see a minus 27 and a plus 27. So you're subtracting and you're adding, there's no canceling. The only time you can cancel is if you're doing straight multiplication. Okay? So, what do I do to proceed? I suggest that we factorize where possible. And when you factorize, now you have multiplication, 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 all multiplications occurring, then you might be able to cancel. Now, look at B squared minus 81. Let's look at that. That should ring a bell from when we were factoring, when we learned to factorize. Because B squared minus 81 looks to me like it's B squared minus 9 squared. So this is something squared minus something squared. It has a name, and it's also very significant in math. It's called difference of squares. In math, another word for subtract is the difference. Find the difference, you subtract. So you see the minus is the difference, okay? If I ask you, what's the difference between their ages? You subtract. What's the difference between their weight? You subtract. What's the difference between their wealth? You subtract, okay? And then this is a square. B squared is B to the second power. And this is a square. 81 is 9 squared, is 81. And we discussed previously that difference of squares is one of those beautiful factorization. If ever you have A squared minus B squared, it's going to always be A plus B times A minus B. This is the factorization for difference of squares. It's always work. Because whenever you have these different signs, the middle terms will cancel out, always, always. So this is actually B plus 9 times B minus 9, because the middle terms will cancel. I'm going to do that with this to show you that this is going to cancel to become just this. Look at this. A times A squared. A times negative B, negative AB. B times A is BA or AB. You always write it in alphabetical order. And then B times negative B is minus B squared. Look at this. Minus AB plus AB. They cancel. So it doesn't matter what numbers these are. As long as you have these, and they're the same here with a different sign in the middle terms will always cancel. So you must keep this in mind because it's a very important concept. It's called difference of squares. So that was a quick review. So now we're ready to factorize completely. So now we have this right here becomes B plus 9 times B minus 9 times this becomes, if I factor out a 3, I end up with 3 times B minus 9. Because notice, this can be, 3 is common to 3B and 27. So I could factor out a 3, there's a B. Factor out a 3, there's a 9. Look at it. 3 times B, 3B. 3 times negative 9, negative 27. the bottom, by the way, just a little aesthetic. Always put your equal sign in line with the vinculum. It's a good practice, your equal sign in line with your vinculum. And the bottom is b minus 9 times b minus 9. That's what the square means, that you write it twice. And this part here is 3 times b plus 9. What goes on now? Well, if I look at this properly, I see this cancels this. Look at this again, I see a b minus 9 and a b minus 9. Look at this again, I see a b plus 9 and a b plus 9. And look at this, I see a 3 and a 3. So everything on top is replicated in the bottom. So they are identical top and bottom. So at the end, anything divided by itself is 1, except 0 divided by 0 is undefined. It does not exist. So the final answer to this question is 1. So look at what we started out with. All of this simplifies to just 1, just because we know how to factorize and we know how to cancel when multiplying items on your top and on your bottom. Okay, so that was a little bit more engaging, much more involved. Let's go to another question now. And now we're going to try multiplying something similar to this one. Again, I told you I'm going to go as slow as possible so that you can digest this process. Okay, here we go. I'm not sure what the count is, but I'm going to call this number 5. Here we go. No, number 6. This is number 6. So we have x squared plus x minus 42 over x squared minus 36 times x squared minus 49 over x squared minus x minus 42. Again, each question seems to go to another level. And we're going to say, we're not scared. We're not scared. We're going to just take it step by step and see what happens. Okay, so here we go. I suggest we try and factorize as much as possible. So the x squared plus x minus 42, I think, is going to be x plus 7 times x minus 6. I am not teaching how to factorize in this session. I've already done that. There is another session that deals with how to factorize trinomials. Especially if you have the leading coefficient of 1, they are very easy to factorize. You need two numbers that multiply to give you negative 42 and add to give you positive 1. 7 times negative 6, negative 42. 7 plus negative 6, positive 1. There it is. Look at the bottom. Again, this is x squared minus 6 squared. That's a difference of squares. And we just talked about how to factorize difference of squares. So we know this is going to be x plus 6 times x minus 6. We just had x squared minus 81, b squared minus 81. So we see the same concept coming back here. Over there, again, difference of squares. We have x plus 7 times x minus 7. That's what happens to the top. And the bottom becomes x minus 7 times x plus 6. Again, factorizing trinomial is another session that we have done, so you have to look at that if you're not sure. And now we have factorized everything. Everything is multiplication. We are multiplying a binomial times a binomial times a binomial times a binomial. binomial times a binomial times a binomial. So now we are doing straight multiplications. So therefore we can cancel, if possible. So I look at x plus 7, x plus 7, there's no x plus 7 on the bottom. So we can't touch that. I look at x minus 6, x minus 6. I look at x minus 7, x minus 7. So what do we end up with? I see x plus 7 squared. That's an x plus 7, and that's an x plus 7. What do I say at the bottom? X plus 6 and x plus 6. And that is the final answer. You cannot simplify that. So that's where you stop. Okay? Train keeps moving. Okay, here's another one. P squared. Okay, let's use lower cases. P squared Q over PQ squared divided by P squared over Q. So before we dealt with multiplication, now we're going to division. So before we do division, let's go back to fractions, regular fractions. If I gave you, so this is a sidebar. If I gave you 4/5 divided by 3/10. Just suppose 4/5 divided by 3/10. The rule in math is that whenever you divide by a fraction, you flip the divisor and multiply. So you flip this and change the division to multiplication. So it becomes 4/5 times 10/3. That's how you do it. You change the division to multiplication, you change your divisor by flipping. The bottom becomes the top, the top becomes the bottom. So there it is. And now we're back to what we were doing all along. 5 goes into 5 once, 5 goes into 10 two. So the answer is 4 times 2 is 8/3. So again, how do you divide by a fraction? You flip and multiply, you flip and multiply. So that's the same principle we're going to use for rational numbers when you're doing division. So here we go. So I just use the sidebar to explain the point or explain the principle. Now we're going to apply the principle to this question. So what do we have? Well, I could have simplified this, but we already started, so let's go. We're going to flip this and change it to multiplication. So it's P squared Q over PQ squared times Q over P squared. I flip this, so the Q goes to the top and the P squared goes to the bottom. And then the division now changed to multiplication. And we have been doing many examples with the multiplication, so this is like boom, boom. Okay, here we go. P squared here, they cancel. Q is on top, Q squared on the bottom. Oh, wait a minute. Q times Q is Q squared, and there's a Q squared here. So this and this get q squared, and that's a q squared. So what are we left with? The top just has 1, and the bottom has 1 times p. So it's 1 over p. So this entire expression simplifies to 1 over p. How cool is that? Let's go to another one. Let's do something that's a little bit more involved. Number 8. Number 8 says a squared plus 4a minus 45 over 4a minus 36 divided by a squared minus 81 over 5a squared minus 45a. So that's a question. Let's see what happens. The math doesn't change. The math does not change. Keep that in mind. The figures might change and the expressions might look more complicated, but the basic principles remain the same. You're dividing by a fraction, so you're going to flip and then change the division to multiplication. And as before, we're going to try and factorize as much as possible so we can see what can be canceled. Good stuff. Here we go. So this becomes a plus 9 times a minus 5. The bottom becomes, and like I told you before, you keep the equal sign in line with the vinculum. The bottom becomes 4 times a minus 9. Then we're going to change the division to multiplication. And we're going to put this on top and put this on the bottom. And if you will allow me, I'm going to just factorize at the same time. So this goes to the top, and I'm seeing 5a times a minus 9. Look at this. 5 is common to the 2, and a is common to the 2. So take out the 5a, we're left with a, because 5a times a, 5a squared. 5a times negative 9, negative 45a. And for the top is difference of squares. It's a squared minus 9 squared. So we know that that becomes a plus 9 times a minus 9. Again, I'll say it again. I'm using math that we have already done in previous sessions. Factoring trinomials, factoring quadratic expressions. I've exhausted that in a previous session. So if you need to go back to that and then come to this, that's okay. But I'm just letting you know where it is, okay? And here we go. What do we have? I think we have a few things that can be simplified. First of all, I see a minus 9, a minus 9. Then I see a plus 9, a plus 9. Now what else is left? Okay, I see a 5a, a minus 5, 4, and an a minus 9. So I can go ahead and write 5a times a minus 5. I could have written it as a minus 5 times 5a, but this looks better. Over, the bottom is just, what is here? 4 times a minus 9. So this is what we started with. And this is a simplified version. So this is equal to that. Okay, how did we get there? we factorize, and we change the division to multiplication, and we flipped the divisor. So the bottom goes on top, and the top goes to the bottom. Okay? Let's look at another question. We're making progress little by little. So we have done multiplication. And what was this one here? Oh, this one is a little bit more involved. This one is a little bit more involved. We're going to do, okay. Okay, so let's see what we're going to do with this one. Okay, so this says, this is number 9, I think. So this is 6y squared minus 17y plus 5 okay, over 10y squared minus 25y times 30y cubed plus 75y squared over 4y squared minus 25. Okay, this is a lot of stuff going on right here. Let me just pull this forward a little bit. Okay, I'm gonna double check to make sure I copied it correctly. 6y squared minus 17y plus 5 over 10y squared minus 25y times 30y cubed plus 75y squared over 4y squared minus 25. Yes, a lot of stuff going on here, but the principle doesn't change. So we just have to go step by step. So when I look at this, I say, whoa, the lead coefficient is 6, it's not 1. So this is where you do the AC dance that I taught in a previous section, how to factorize quadratic trinomials, okay? Where the lead coefficient is not 1. So that's a session all by itself. So all I'm going to do is I'm just going to use the knowledge and let you go do the research if you're not up to it. Okay, so here we go. This is going to give you something like this, 3y and then 2y is here, and then it's minus 5 minus 1 over the bottom is going to be 5y times 2y minus 5. Let's check if this will work. Let's check the top. 3y times 2y, 6y squared. 3y times negative 5 is negative 15y. Negative 1 times 2y is negative 2y. Negative 15y minus 2y, negative 17y. Negative 1 times negative 5, positive 5. The bottom, 5y times 2y, 10y squared. 5y times negative 5, negative 25y. So this is a multiplication. So I'm going to try and factorize where possible. I say 15 can go into 30 and 75. So I'm going to take out 15y squared times 2y plus 5. And then the bottom becomes, sidebar. Let's do a sidebar. 4y squared minus 25. This one, they will do a cheap one on you to try and trick you. This is a perfect square. This is a perfect square. It's actually 2y squared minus 5 squared. So it's a difference of squares, difference of squares. So if you realize that, you realize it's going to be equal to 2y plus 5 times 2y minus 5. So that's what that's going to be. 2y plus 5 times 2y minus 5. Let's check to see if it's true. 2y times 2y, 4y squared. 2y times negative 5, negative 10y. 5 times positive 5 times 2y, 10y. Positive 5 times negative 5, negative 25. And look at the two middle terms, they cancel. So what are we left with? 4y squared minus 25, 4y squared minus 25. So it works. Okay, so the sidebar is over, point made. Let's erase. Okay, so we have factorized this. Now we're going to see what can be canceled. So I see 2y minus 5, 2y minus 5. I see 2y plus 5, 2y plus 5. I see 5y, and I see 15y squared. So this cancels this. We end up with 3y. So what do we have? We have 3y over there. So I can put 3y times 3y minus 1 over 2y minus 5. You can put the parentheses, but you don't have to because there's nothing else in the bottom. If you put the parentheses, it's not incorrect, but it's not necessary. Okay, so this is what we started out with. This is what we ended up with. Okay, so that's that for that one. Let's look at another one. Let's see if we could do some additions now. How much time do we have? Okay, let's see if we could. I think we're going to need 3 sessions for rational expressions. 3 sessions, because I'm not trying to rush. Okay, so number 10. Number 10. Okay. Number 10 says, x squared plus 3x over x plus 2 plus 2x plus 6 over x plus 2. So what do we have? We have a fraction plus a fraction. We ask ourselves the questions, how do we add 2 fractions? And the answer is, we must have a common denominator. What does that mean? The bottoms must be identical. If they are not identical, you cannot do the addition. So if they are not identical, you will have to find a common denominator. So this is x plus 2, this is x plus 2. Oh, we have the same denominator already. So we have a gift. Because they have the same denominator, we can combine them straight away. So this becomes, same denominator is x plus 2. So now we can just do the addition. It's x squared plus 3x plus 2x plus 6. All I've done is put them on the one denominator, over one denominator, which is x plus 2, and then we just add the numerator. That's how we do it in math. For example, if I gave you 1/6 plus 4/6 you know that that's common denominator is 6. 1 plus 4 is 5. So the answer is 5/6. If I give you 1/4 plus 3/4, everybody knows that the same denominator is here. So it's 4, and 1 plus 3 is 4. So it's 4/4 is 1. 1/4 plus 3/4 is a whole, is 1. So it's nothing new that we're doing. We're doing the same math. Nothing changes. All that happens is we have variables. We have a letter, and that makes it into a rational expression, but it's still fractions. Okay? Good. And then now that you have that common denominator, let's see how we could finish this job. So now we end up with x squared plus 5x plus 6 over x plus 2. And if you're looking carefully, you will notice that the top can be factorized. We will end up with x plus 3 times x plus 2, all over x plus 2. How do I know that? Because you need two numbers multiplied to give you 6 and add to give you 5. 3 times 2 is 6, 3 plus 2 is 5. So there it is. And what do you see? X plus 2 on the bottom, x plus 2 on the top. So they cancel. So our final answer is x plus 3. So look, we had two fractions, and now we have a simple binomial, linear binomial. X plus 3 is the final answer. And that's it for that one. Okay? We have been working for 1 hour. I'll do one more question, and then we call it a day for today, okay? Good. Number 11. I hear somebody saying, make it 12, make it a whole number. So this is 11. 7x, make it a dozen, sorry, not a whole number, make it a dozen. So it's 7x plus 3 over x squared minus 1 minus 6 over x minus 1. So now we see that we have two different denominators. So we want to subtract, but the denominators are different. So what do we do? Well, let's see something. If I gave you 1/3 minus 2 9s. In order for you to do this, you're going to have to change these denominators so that you have the same denominator. Or you have what is called a common denominator. So in this case, I could change this denominator to 9 by multiplying this by 3. But if I multiply the bottom by 3, I have to multiply the top by 3. So this becomes 3 over 9 minus 2 over 9. Now that I have the same denominator, I can do the subtraction. Put them together as one fraction. We end up with 3 minus 2 over 9 equal to 1/9. So by changing the denominator here, we end up with something with the same denominator as the other one, and then we can subtract. Okay? So that's the same thing we have to do over there. We have to find a common denominator. My recommendation whenever you get a question like that is always try to factorize your denominators as much as possible. Then you look for your common denominator. So for that one, I noticed that this is a difference of squares. It's x squared minus 1 squared. So we have 7x plus 3 over x squared minus 1 squared. And then this gives me 7x plus 3 over x plus 1 times x minus 1. So that's what this is. That will give you this x squared minus 6 over x minus 1. So now we're in a position to get your common denominator. You have an x minus 1, you have an x minus 1 and x plus 1. So this is a bigger denominator. So I need to multiply this by x plus 1, and I would have the same denominator. So therefore, I would put this equal to x plus 1 times x minus 1. So this denominator is already this. So the top doesn't change. We have a minus. Now, this denominator had to be upgraded to get this. So what did we have to do to the denominator? We have to multiply it by x plus 1 in order to make it have the same denominator as this. So if I'm multiplying the bottom by x plus 1, I also have to multiply the top by x plus 1. So it's now 6 times x plus 1. So now we're in a position where we simplify the top and see what happens. So it's 7x plus 3, negative 6 times x, negative 6x. Negative 6 times 1, negative 6. Over x plus 1 times x minus 1. 7x minus 6x is x. 3 minus 6 is negative 3. And the bottom is x plus 1 times x minus 1. There is nothing to simplify. You can't simplify it because there's nothing to cancel. So that would be your final answer. Okay? Many times you would end up with an expression that can cancel further, but in this case, you can't. So just leave it alone. You can't force it to simplify further. Okay? Well, welcome to rational expressions, simplifying rational expression. We still have more work to do. And then, of course, we're building up to where we solve rational equations. We're not there yet. We're taking it in stages. But for today, we are very comfortable in that we have made a start. We'll continue this progression in our next class. Okay? On behalf of the Brosis Foundation, we thank you for spending this time with us, and we hope that you find these sessions useful and helpful. Remember, we have both math sessions and also English sessions. So you do enjoy the rest of your evening, and hopefully you will tune in for the next sessions. And also, we have already done 29 of these sessions, 29. This is number 30. 29 videos already created. This is number 30. So thank you for joining us. Enjoy the rest of your day.